In this video, I will show the end behavior of polynomial functions. Recall that polynomial functions are of the form f of x equals an x to the n plus an minus 1 times x to the n minus 1 plus ax plus a0. So this is a polynomial of degree n and leading coefficient an. So the end behavior means discussing the values of y when x becomes very large in magnitude. In other words, we're going to look at making x very large, like x approaching infinity or x approaching negative infinity. Then we're going to look at what happens to the values of y. So the easiest polynomial is a line. So let's say y equals x. This is a polynomial of degree 1. So if you grab this line, you will see that when x becomes larger, so here's x and here's y. When x becomes larger, let's say from 10 to 100 to 1000 and so on, we notice that y's become larger. With other words, when x goes to infinity, y is increasing and increasing to infinity. Y goes to infinity. We also look at what happens to the y's when x becomes very, very small. Let's say we start at negative 10 and then we go to negative 100 and negative 1000. We're looking at the y values. Like in this line, we have the y values to be negative. So when x is negative 10, y is negative 10. When x is negative 100, y is negative 100. So we notice that when x approaches negative infinity, y approaches negative infinity. Let's look at the parabola. Y equals x squared. We know how the graph of parabola is. So again, we're going to see what happens to the y values when x approaching infinity. Infinity means we're going with a small value of x, let's say 10 again, 100, 1000, 10,000, and so on. We notice that when x is 10, y is 100. When x is 100, y is 100 squared, and so on. So we see that when we make x very large, y is very large. So y increases without boundaries, so y goes to infinity. And we see it from the arrows as well. X goes this way, y goes this way. Now let's look at on the other side. We start at -10, -100, -1000, and so on. So we're going on negative infinity for x. So when x goes to negative infinity, what is happening to the y's? Well, when x is -10, y is 100. When x is -100, y is negative 100 squared, which is the same as 100 squared. So we notice that y is increasing without boundaries, so y goes to infinity. Okay, it turns out that in general, the end behavior depends only on the leading term. So I'm going to look at y equals 3x to the third plus 5x plus 2. The degree of this polynomial is 3, and leading coefficient equals 3. When x becomes very large, so let's say x goes to positive infinity, what happens with the polynomial is that 5x plus 2 kind of become invisible, and the function behaves like the leading term alone. Okay, so instead of just looking at the whole value by plugging in x values for every x, we're going to look at only the leading term. So when x goes to infinity, what happens to 3x to the third? So 3x to the third is the same as x to the third. So we kind of got to remember these graphs. This is y equals x to the third, and y equals 3x to the third behaves just like this for very large values of x. So in this case, when x goes to infinity, y goes to infinity. When x goes to negative infinity, by looking at the graph of y equals x squared, we're going to have y goes to negative infinity. This is called the leading term test. So let's look at y equals 4x to the 6 plus 3x plus 2. We're going to look at only the leading term. So our graph will behave like y equals 4x to the 6 for x going to plus or minus infinity. And 4x to the 6 behaves like a parabola. Which means when x goes to infinity, y goes to infinity. When x goes to negative infinity, y goes to infinity. So as a summary, to study the end behavior, we look at the leading term. So we're going to look at if degree is even, function behaves like a parabola. what happened in between, we study the x-intercepts. Parabola can open down, so when the leading coefficient is negative, function will behave like a parabola going down. Negative leading coefficient. When degree is odd, function behaves like the third degree polynomial. So leading term positive, function is going to be like the function y equals x to the third, something like this. And when the leading coefficient is negative, function is going to behave like negative x to the third.